Yeah, so TAS3 is a research project. It's an IP with 17 partners. And one of the challenges of TAS3 is actually that we need to bring together security, privacy and trust together. The thing currently is what we get from research-wise technology is we have different pieces, independent, and the challenge of TAS3 is to bring everything together, implement this into a framework, and then fill the gap whenever it's needed to be sure that the platform TAS3 architecture can provide everything for the end user. Yeah, one of the things which is quite special with TAS3 is that actually it combined together one of the existing projects, and that's one of the first time that you can really get an end-to-end secure framework like this. So this is one of the aspects. Then also TAS3 is really user-centric, so if we want to think about adoption for end user, we need to think about the user, and we need to provide him a way to control his data, to give him some more empowerment on how and who and when the data of a user is accessed. So TAS3 is providing all these features within the same framework, so the user is really in control of everything that happens. But still his data is also secure and controlled in trust by the framework itself. On the other hand, we know that technology cannot resolve everything. So even if the project targets the most and the best you can do and offer to end users, we were a bit realistic with an industrial vision, in the sense that we know that technologically we can implement a lot of things, but on top of this we also define a legal framework that define obligation bindings for partners, for service providers, and all this together makes this framework, if implemented correctly, a real secure place for end users. At the end of the project, so TAS3 offers for sure a full set of protocols that enable anybody to implement the architecture and build his own trust network where everyone will be able to connect to and share services. But on top of that, we also demonstrated a fully working architecture with lots of different components and so-called reference architecture, and which is totally available as well. So that means that everything we've developed as components are open source, free to use. People can pick them up and try on their own if they can or they want to implement this as well. So I believe that the end of the project is an easy way, if we can say about easy way of implementing such complex architecture, but people can really pick up things, make a try, and provide something more secure for end users.
I'm Sampo Kellomäki, the lead architect of the TAS3 Trusted Architecture for Securely Shareable Services with Privacy, and also the CTO of Synergetics. Effectively, we started from an observation that a lot of the technology for privacy-friendly stuff and for security, digital signatures, all that kind of existed, but nobody really had put it all together. And we were feeling that the way the internet is developing, there's lots of pain points for the normal end users. Users feel that they are not in control, their data is kind of scattered all around. And what we really wanted to do is use these technologies that already exist to give the data back to the user, give the user control, and make the user feel safe so that he can trust the players in the network, trust the service providers to behave properly. And once they do trust, they are more willing to use the systems and effectively open new markets, new applications which weren't really acceptable to the users prior to this system. Effectively, to do this, we set up the TAS3 project, where we are trying to combine in a holistic way legal framework, legal contractual framework, intake processes so that we make sure that we only let the good players into the network, technology for single sign-on, authorization, identity-based web services, privacy preservation through pseudonyms, audit trail, and then of course a online compliance validation system where we check automatically that the players, the service providers in the network play by the rules. Now then the user uses a service, but this service typically doesn't do in a monolithic way everything. Instead, the service will be calling other services to do its job. And one of the most important services we want the service to call is the user's personal data store. So we don't want the services to hoard data about the users. Instead, we want the user data to be in a place where the user can control his data. so that these services receive the data from the user, and the user can impose policies on the data, policies such as intended usage or acceptable usage, data retention, so when does the company have to delete it. Also, important European Commission initiatives like right to be forgotten, so that essentially the user can signal to the services that use the data that they have to delete it, or that they have to rectify it. So our architecture and technology puts all of this together and essentially gives the power back to the user. But it is also good for all the service providers in the network, because first of all, they can plug into a bigger base of users. They don't have to have separate registration processes for the users. Instead, they can leverage the users that already exist. They also get a very rigorous technical basis, essentially auditability, non-repudiability. So all the other players have to play by the rules. If they said that they would do something, they are digitally signed and bound to actually do it. We also have user audit features, so the user can see how his data was used. So let's say user goes to a website, initiates a process such as being employed. In this process, there might be many other players that user isn't necessarily initially very much aware of, but the user can go to a dashboard and see some audit records there. I see this placement provider has also accessed my data. And then if user thinks this was perhaps something he didn't want, he can drill into this audit trail and see exactly why did this happen. He can also do policy editing and actually forbid it from happening again. And in the extreme cases, he can even use this as an evidence in court of law to actually catch the abusers.
Hi, I'm Jared Hertog from the Technical University of Eindhoven, where I work in the security group on security and trust management. So in TAS3, well, as the name implies, trust comes first, right? So you have the trust network, which is an environment in which you have vetting of services and contractual obligations to support the TAS3 technology to be able to build trust. So TAS3 technologies are the dashboard, which allows users to see what they're doing with what's being done with their data, and the privacy-friendly identity management. So this creates an environment in which you can actually start building trust. Now, trust is a subjective thing, so in TAS3, right, we allow the users to build trust according to their requirements. And we do this by offering a trust management system which is able to express and evaluate multiple factors of trust. So trust ranking and negotiation in TAS3 work by evaluating and enforcing trust policies at the right moments in time. Now, for trust evaluation, this means that whenever a user's personal data is being used or a service's resources are being consumed, their trust requirements are being checked. To be able to check trust requirements, we have to gather different types of trust information and evaluate them, such as the feedback from other users or the credentials stating facts about a service. Now, trust negotiation takes care of the situation where you have credentials that I need to trust you, but right, you say, oh, show me yours and I'll show you mine. So you're only willing to give them if I prove that I'm trustworthy, because the credentials themselves might have sensitive information. So a key benefit of TAS3 is that it puts the user in control of trust, right? So if you think of situations like, for example, secure web browsing, then you have the same requirements whether you're just reading a news item or whether you're doing online banking, right? But the user will have different trust requirements in these situations. So in TAS3, you're able to distinguish these two cases. We've done a user study looking at the perception of trust and seen how these differ in different settings. And with the TAS3 setting, you're able to allow a user to, well, adjust their trust to their perception and allow a service to build those factors into their service which the user needs to trust the service.
I'm Jutta Müller. I'm coming from the Karlsruhe Institute of Technology, and I'm researcher and lecturer on the domains of workflow management systems and information systems. In TAS3, our focus is on supporting privacy and trust properties and to provide secure execution of the tasks and the whole business process flow. So that's the way we do not only support the execution of the business processes as it is usually done in existing commercial business process management systems, but we also support to identify the users, to authenticate them, and also to get more and better improved functionality to authorize the use of tasks, execution of tasks, and the use of data. TAS3 business processes differ from other workflow management systems in that they provide much more support for security and trust. So, for instance, we have integrated authentication and identification of the users in a much more comprehensive way, and also related to a federal identity provider environment. And we allow for more authorizations which are taking in account also the execution of tasks, which is not done in normal business process management systems. Service providers need to develop their own secure business processes, but they are supported by our components and tools. We are starting with the modeling and configuring part, and we allow to model security in respect to business processes. So, modeling the business process with a usual diagram technique and tool is enhanced with security modeling. And the next part then will be done automatically by our tools, the transformation to the execution phase. One example would be also that we allow users to define their preferences in respect to a selection of services according to their trust level they want to achieve. So they are asked which service out of the selected and discovered services they want to run. And maybe if there is no service discovered, there might be an iteration allowing the user to mitigate the trust level.
I'm David Chadwick from the University of Kent, where I'm a Professor of Information Systems Security and I lead a research group there. TAS3, it's a privacy-preserving infrastructure for personal data that allows people to have confidence and assurance that the personal information they submit into the various services in the infrastructure are going to respect your policies, they're going to look after your data, they're going to keep your privacy, they're not going to tell people who you are, what information you've got, and they're not going to pass it on without your authorization. The sticky policy infrastructure is important because it allows users to say what their policy is for access to their personal information, and their policy is then stuck to their personal data and it travels with their personal data throughout the entire system. So no matter which component of the system holds their data, the data and the sticky policy go together. This ensures the user's wishes are always followed so that no one can access their information without the user's policy being evaluated. The natural language policy editor is a way that we're trying to allow people to set their policies in an easy and intuitive manner. The way that policies are written in computer-based systems is they're written in computer-based languages which humans find very difficult to read and understand. Computer programmers and computer scientists can understand the policies and they can write them, but general managers and the man in the street is not capable of doing this. Therefore, they have to have an interface to allow them to specify their policy. Now, the interface might be a simple, what we call graphical user interface, where they just click a few buttons, or what we've developed is a natural language-based interface which allows them to type their policy as English sentences. The Trusted Attribute Aggregation service is important because people have lots of different identity information provided by different authorities. For example, your bank knows something about you, the government knows something about you, your local council knows something about you, your employer knows something about you, but they don't all know everything about you, and they don't all know what the others hold. Only you know that. And the Trusted Aggregation service allows you to configure which information from which authority you are happy to release when you go for a service on the internet. Break the glass is important because computer-based systems typically only give grant or deny answers, and if an emergency situation arises or an exceptional circumstance arises, you may want to gain access when the system denies you access. And break the glass allows the accessor to make a decision that this is important, it's emergency, and I should have access, and I know why I should have access, and I can justify it to management later. And the break the glass system allows the user to break the glass, get access to the information, it sets off alarm bells, it tells the manager, and then the user has to justify it later.
If you have any more questions, you're also advised to go to the TAS3.eu website, or you can see the reference implementation at the zxid.org website. Thank you.